first part is translations only from memory. Okay. Something very important to remember. Okay. 3 basic types of transformations that we're looking at. Dilations from each of the coordinate axes, the x and the y. Reflections in each of the coordinate axes, x and y. And translations again in each of the axes, x and y. Okay. So the easiest way that I remember it, if they're talking about a translation, okay, so plus or minus, so up or down, left or right, we put it on the actual axis itself. So if we're talking about a positive translation along the x-axis, we add k units on the x. If we're talking about positive, or whatever, h units, sorry. If we're talking about k units in the y, we add k units along the y. If we're talking about a negative translation, we still do the same things. We're only talking about translations here. Okay, so it all goes on their respective axes. So h units along the x-axis becomes x minus h. K units negative direction of the y becomes y minus k. From there, we can get our image for both of it. So here, the x minus k is the image. X minus h, sorry. And here, the image is y minus k. Now, of course, we move the same distance every point on the graph. We move that same distance. So let's do an example. We'll clear that. Okay, just showing you the same distance moved. This one is mapping. X gets added 2 and y gets added 4. So 0, 0 will go to 2 and then up 4. Negative 1, 1 will go across to 1, because add 2 to the x, up 4 to the y, so add 5. The 1, 1, add 2 to the x becomes 3, add 1, 4 to the y becomes 5. And we get our new rule. But I'm going to show you how to do these, so don't stress out. Okay, again, just showing you in a picture. Okay, you should probably already know this. 1 unit in the positive x direction, okay, becomes from here, it shifts 1 unit and the y stays there because there's no translation along the y. 1 unit negative x direction, from the 0, 0 goes to the negative 1, and that's it. There's no translation up along the y. Positive direction of the y goes 1 unit from 0, it goes 1 unit up. From 0, 1 unit down if it's a negative translation. Okay, am I giving you any information that you don't know?
No.
Okay, well, at least one person answered, thank you. All right, example 1. Better bring my annotation up. Find the image of the point negative 2, 5 after a mapping of a translation. Okay, this one says 2 units in the positive direction. So on the x value, we're going to add 2, and 3 units in the negative direction of the y. So on the y value, we're going to subtract 3. Okay, so negative 2, I'm adding my 2, there it is in red. My 5, I'm subtracting my 3, so I get 0, 2. So this 0, 2 is the image of negative 2, 5 under this transformation. Right, part B, defined by the rule x, y. Okay, with x, remember, I'm still, okay. So x defined by the rule x, y. So with x, I'm doing negative 2 and, well, not, it's not there. Now, x, y is such that x go minus 2 and y plus 2, okay. So my x values are getting 2 subtracted. My y values are getting 1 added. Okay, that's all that's happening there. Any questions there? So negative 2 and 5, because I don't know why I didn't, yeah, oh, there it is. Negative 2 and 5 becomes negative 2, and we are subtracting the 2 because that's what it says for us to do. Put the x value in there, put the y value in there, and minus 2 for the x, add 1 for the y. So negative 2, we're taking away 2. With the 5, we're adding the 1. So negative 2, 5 goes to the points negative 4 and 6. So the image of that negative 2, 5 under this transformation is negative 4 and 6. Now they're easy, they're just points. Okay, that's not hard. Let's look at when we have a function, and we have to do this because we have to find the image of this function under these transformations. In this case, they're only translations. Okay, the question says find the equation of the image of the curve y equals f of x, where it's 1 divided by x under a translation 3 units in the positive direction of the x-axis, so we're adding 3 to the x, and 2 units in the negative direction of the y-axis, so we're subtracting 2. So that's how we get those ones there. So the image, and I know I've explained it there, but I'm going to explain it again. The image of x is x plus 3, and y image is actually y minus 2. But I don't have that in my rule. My rule says y equals 1 divided by x. So I'm going to rearrange this one here and make x the subject. So I get x equals x dash minus 3, and the same for this y equals y dash plus 2. That's how I get those ones there. Okay, now I'm substituting into my rule. So therefore, y equals 1 divided by x, image is, instead of y, I'm going to put the y dash plus 2, and instead of the x, I'm going to put the x dash minus 3. And then I'm going to solve for y, because the original question was as y equals. So rearranging this, I'll get rid of the plus 2 and it becomes minus 2 on the other side, and that's how I get that part there. And therefore that is the equation of the image. You don't need to write the dashes anymore as I've written here. Any questions there? Okay. In case anyone wants to write anything down, I'll just take 10 seconds and let you write anything down that you're after and stretch. Okay, I'm about to clear it unless someone says no. Okay. Example 3. I think this hopefully is the last. Oh no, there's another one. Example 3. State a transformation which maps the graph of y equals f of x to y equals f1 of x for each of the following. So x squared, that's our original graph, and we're gone to x minus 4. So if I graph this, that looks like that. And if I graph this one, x minus 4, it's going to now cross at the 4. So what's happened? We have translated it 4 units in the positive direction of the x-axis. I know inside it looks like a negative, but remember, that's how we'll write the x's. It's always the opposite. It's gone to the 4. Because we go x minus 4 equals 0, x equals 4. So any questions on that one? Okay, part B. The original graph is y, or f of x equals 1 and x. So I've still got my original graph, but I'm subtracting 2. Subtracting 2, we translate it 2 units down. So 2 units in the negative direction of the y-axis. Any questions there? Okay, again, I'm going to clear it in a sec. And example 4. And this is the last one for today. And it says for y equals f of x, sorry, f of x equals 1 on x squared, sketch the graph of each of the following. Okay, so if we remember, 1 on x squared is a truncus. Okay, a truncus, it has asymptote there and there. So y equals 0 and x equals 0. But that's what it is, a truncus. Okay, but what's happening? We are translating it minus 1 unit. So really we're doing this. Y equals 1 divided by x minus 1 squared. That's what we're doing for part A. We substitute x minus 1 in there, we get 1 divided by x minus 1 squared. So this is still a truncus because it's a squared, but we are translating it 1 unit in the positive x direction. So we get our asymptote at x equals 1. Still a truncus, just move there, and of course the asymptote is still at y equals 0. Then the next one, excuse me, which I'll do in green, part B. Okay, we've got f of x, which is 1 on x squared, and we're adding the 1 outside. That's our graph. So this is still the truncus, but it's not translated along the x-axis. No x translation. It only is being shifted, translated up 1 unit. So the new asymptote for the y is at y equals 1. The x asymptote still remains at x equals 0. Still a truncus because 1 on x squared. Any questions on that one? Okay, that's exercise 3A. Now I did say, and let me clear this.